Okay, hi Sandy and anybody else who's interested in me going through the answer to this question. Um, I'm just looking at this now and I'm thinking, okay, so it's a vectors question. It's got I's and J's in it. You know how much I've spoken about how much I hate those I's and J's. And I see this line here. The acceleration of the boat is constant. And as soon as I see something like that, I think Suvat. So I know this question is going to be built around the Suvat equations. Now, um, I'm going to do the whole question. I know you only asked for 8 part C, but I'm going to do the whole question anyway because I like to settle into a question, especially a vectors question like this. Now, they tell me first at time t equals 0, the speed of the boat is 0.6. Now, that's always a bit annoying, but it does tell me it's moving due north, which means I do actually know its velocity, not just its speed, and I can state it straight away. Its velocity, if it's moving due north, bearing in mind that I and J are due east and due north respectively, that means the velocity vector is 0, 0.6. Yeah? And relative to O, the position vector of the boat at time t is r meters, and at t equals 15, the velocity of the boat has changed. It is now 10.5 minus 0.9, yeah? And in fact, I'm going to change that v, which I wrote down earlier, to a u for obvious reasons. That's the initial velocity, if you like. So let's see if I can craftily kind of change that into a u. It was as if the mistake never happened. And this is going to be my v, yeah? And I can clearly see that 15 seconds has elapsed from the very beginning. So to find this acceleration, I could just use v equals u plus at, and that's what I'm going to do. 10.5 minus 0.9 equals 0.6 plus a, and the acceleration vector I'm going to call xy times by 15. And so now I can find xy by rearranging this vector equation. I can subtract that over there, so I get 10.5 minus 1.5 equals 15xy. And then I can divide both sides by 15. And so I get xy equals, and dividing the vector by 15 is the same as like doing 10.5 divided by 15 and minus 1.5 divided by 15. Now I'm going to check it on a calculator because I know I could just say, well, that's the answer, but I want to check that I've definitely got the answer. Yep, that does indeed give me 0.7 for the x coordinate. Minus 1.5 divided by 15, well, that is obviously minus 0.1, just as they said I would get. And so that completes part A. And I know that wasn't a stress for you, but I might as well go through the whole question. Okay, so that's part A. Find R in terms of T. Well, this is really the bit of Suvat, which is S equals UT plus a half AT squared. Yeah, but don't forget that you do have to worry slightly when using S equals UT or R equals UT plus a half AT squared. We can use this equation. And that's the thing. I bet my way of doing this probably looks very different to the completely valid approach, which is shown in the solutions. Yeah, I know my way of doing things with vectors can often seem quite different. So yeah, I do understand that. Okay, so if we've got this, the reason why I don't need you, I was slightly worried. I was going to say you sometimes need a plus S0. Yeah, and this is sometimes called S or R. They're calling it R here, but we're calling it S. Well, the reason why we don't need that this time is because the boat is at the origin right at the beginning, and therefore S0 is 0, 0. So we haven't got to worry about that. Okay, let's actually give myself a bit of space and write this down again. So R equals, now my U is 0, 0.6, just as it was before, T plus a half A. Well, we know the acceleration now, so that's going to be 0.35, that's half of 0.7, and minus 0.05, that's half of 0.1, and then a t squared there. And that's my r in terms of t. That's going to help me as well for part C, because in part C, I want to find when the value of t when the boat is northeast of the origin. Now, remember that we're dealing with an xy plane here, and to be northeast, well, that's north, isn't it? And that's east. If you're exactly northeast, you're on the line y equals x, which means that your y coordinate should be equal to your x coordinate. Now remember that r stands for your general position as well. So all you've got to do here is say, okay, my x coordinate, yeah, because this basically equals your x and y for where you are in the screen. Yeah, it's not the same x and y as the acceleration bit though. It's not doesn't I'm not using it in the same sense here. I'm just saying that's your general position. So all I need to do is 0.35 times t squared should equal, that's my x coordinate, 0.6t minus 0.05 t squared, because it should be exactly the same as my y coordinate. That gives me 0.4 t squared when I add that onto there. Let's take away the 0.6 t at the same time to save ourselves a little bit of time. And then let's factorize out and solve. I'm going to take out a factor of, I think 0.2 there because it'll be nice. It'll just, and obviously the t as well. And then I'm just going to have to times that by 2t minus 3 equals 0, and hence t equals 0, or I don't want that answer, by the way, because that's like the trivial case where it's at the origin, or t equals 3 over 2, and that's the time when it is northeast of the origin. And that's that part of the question done. You didn't ask me about part D, so I presume you got that right, but I will quickly go through it just in case you're still wondering. D is different because we want to know when the boat is moving in a northeasterly direction. Now, what tells you about direction of movement? It is the velocity. So it's v, which equals u plus at. So it equals 0.6 plus 0.7 minus 0.1 t. We want this direction. Think of the velocity as an arrow. We want the arrow to be moving in a northeasterly direction. We don't, that could be not when you're northeast of the origin. It could be when you're completely north of the origin or completely east of the origin, that you're heading in that general direction. Think of it as the way the boat is, yeah, it is a boat, isn't it? Think of it as the direction the boat is facing in rather than its general position from where it started. So, okay, now we do pretty much exactly the same thing. We want the x component to be equal to the y component. And then we just solve it. And so we're going to get 0.8t is 0.6. And so t is 3/4, I believe. And that is the value of t when you are northeast of going in a northeasterly direction. Okay, I hope that was useful, Osandi, and whoever else is watching. And best of luck and keep up the hard work with the course. Bye bye.